let's talk about this little beauty right here. There are oblique holes that need to be put into this casting in this area right there. They are put in such a way that when you drill them at 20 degrees, they intersect these little ports on the bottom. Naturally, these holes coming in intersect this port, holes coming in from this side intersect that port. At least that's the intent. Now this is a feature that takes a little bit of planning. They are set on 20 degrees. And I'm sure that for a steam engine, for a model like this, you can probably wing this with one of these. This is a wiggler, right? This thing is like the most lethal fly cutter in the planet while you're trying to get it to spin straight. So don't overdo it. And the natives are restless today out there. Once this starts, once it spins straight, if you wanted to, grab a jeweler's loop, locate this thing by eye on the edge. Okay, fantastic. You know what it is to this edge at 20 degrees. You've done your math. Actually, it's more like this. And then you just make your little shift and pop your holes in. But if you want to do this correctly, and I mean hit the numbers on the print, it takes a little bit of planning. You're going to need to have what's called a tooling ball. This little guy right here. This is the end-all cure-all for putting in oblique features on parts like this. It needs to go right here in the middle. And then you indicate the ball, do a whole lot of math, move over, pop the holes in. Great. How does this go in there? Well, there's the planning part. I made a plug. This plug fits in there just so nice. I know that it's a 100 step from here to here. And when this tooling ball goes in here, it's 500 from the center of this ball to this surface and 100 from here down. So now I have something to indicate. And regardless of the orientation of this part in space, you will always have a round surface, a spherical surface to indicate on. And that is the beauty of this particular device. So with a little creative setup in the mill, we're going to kick this part off at 20 degrees. We're going to indicate that ball, and I'm going to pop those two holes in like nobody's business. But let's go inside. I've got the mechanics about how everything is calculated in the setup on the board. Let's take a quick look at where the numbers are coming from. Okay, theoretically, this is the setup that we have out in the shop. The black on the bottom here, that is the casting. That's the tooling ball, and the red is the aluminum plug that's sit in there. So I know that that tooling ball, and they come in standard sizes, is a 500 diameter, and it sits, the center of the sphere sits 500 above the aluminum plug. The aluminum plug being 100 thick puts that center at 600 off the casting. With the part oriented at 20 degrees, there are two center lines that will need to be established. This is the center line of the machine, right here. As you sweep that ball, zero out your spindles, zero out your tables, you are now over the center of this ball at 20 degrees. At 600 off, the first triangle that falls out is A, B, C, illustrated right there. 600, 20 degrees. This is the chord that you're going to want to know right here, the BC. This little leg right there. In order to do that, it is 600 times the sine of 20 degrees. 600 times the sine of 20 degrees will give you the line segment BC. 205, right there, that little segment. 205. The second one that's going to fall out is the 531 on the print. This is where you want that hole to fall in. Do not make the mistake of orienting the 531 this way. That is not the way it's done on the print. 531 is along the face of the cylinder. Okay, so that's 531 is now here, right there. When we know 531 and you have the 20 degrees because the part is kicked at 20 degrees, 531 times the cosine of 20 degrees will give you line segment BD right here. And once you have those two segments, you simply subtract the small one from the big one and come up with your table shift, 294. 294 is how far we will move over in whatever axis we orient the part to from the center of that ball, come down and have a 531 dimension. It's going to be a creative setup. I think you're going to like what you see. Let's get back to the machine. Off we go. First thing I'm going to do is stick a 20-degree angle block in my Kurt, and I'm going to use a second vise for this. .20-degree angle block. If you don't have one, I have a video on how to make one, so check it out. Sit this in there. Make sure that your vise is sitting on that and not one edge where it shouldn't be. There you go. Nice registration. Now look at now, knowing that the primary vise is doing a lot of work here, take the handle off and put it on your bench. I know if you're like me, it's easy to just finish up a part and smack that handle. Well, that wouldn't end well, so let's not do that. By now the casting should have one face that's completely flat and one face that's got the elevated boss on it. I'm going to start, since this is the one that's tapped, this is also going to be tapped but hasn't been yet. This will be the side that goes up. Flat side against the movable jaw or the stationary jaw. Sits in there just fine. You are still banking on a raw casting at this point. Make sure you use your piece of copper wire, aluminum shim, whatever you got. Part is now correctly oriented at 20 degrees. Let's give you a quick look from the side. Okay, and all we need to do is find the center of that bore, starting point, and that's where the tooling ball comes in. If you do make an adapter like this, make sure it's a dead sharp corner in the edge here or an undercut. You do not want to be above that surface. Let's indicate that. Of course, it's almost black where I'm standing, but you can see it, right? Let's get a little bit of registration and see what happens. if you can see that. I hope you can. In order to make it easy, try to stay above the top section of the ball. Imagine it's just a hemisphere and not a full sphere. Stay above center line. Sweep the ball this way. And I really wish you could see the reading on that indicator, but it's almost impossible to get a camera angle in there. And we are reading -5.5 here, about 5 and 7. 5 and 7. That is within a couple of tenths of being spot on. This is where you change your digital readout, table dials, whatever. Zero everything out right now. Let's make that 299 shift. Excuse me, 294 I believe it was. I'll double check. Let's walk it over and get on center for those holes. After successfully indicating the center of the tooling ball, the x-axis has moved over 294. Each one of these features is 9/64ths or 141 thousandths off center each way. And this camera is right where I need to be standing, but what a great shot. So I'm just going to see if it can work out the way it is. I'm going to plunge this end mill because it's the same size as the hole that's required until I have a full diameter that the drill itself can sit on. Let's see how that works out. Since it's an angled surface and it's an interrupted cut, I'm using the stop on the quill and I'm going to creep it down very gently so it doesn't grab and blow up. That would be bad. Looks like the print, that's a good thing. Two small dimples right where they should be. This is the beginning of the hole. The hole is going to be at 20 degrees. Once those features are put in, the print now requires the part to be reoriented flat and for the slots to be put there. They're calling them ports right into the cylinder. So on location at the 531, but slotted. Let's do the holes first. Drill's in the machine, and the slot that I want it to intersect has now got a piece of white paper in it. Since I don't know how it's going to feel when it breaks through, I am going to watch for that piece of paper to jump around, and I'll know that I'm right there. Let's do it. Alright, having that white paper jump around is a great indicator. You can feel it break through. But the last thing you want to do is drill it too far and hit one of the other ports. So keep that little trick in mind. Stick something in there. It works very well. We're going to switch back and slot those particular features. You need to do this to both sides, but for sake of demonstration, it really makes no sense to film both sides. I'm just going to film this one. The beauty of using two vices like this, I can open up the main vise. I can open up the Curt and lay this secondary vise flat, and I do not have to reestablish the y-axis 0. It will not change. Only the X. So I'll put it back in, sweep it again, we can slot those features, and then take a close-up and show you how it looks. So far, so good. The y-axis on the digital remains at the same setting that you had when you zeroed out with the tooling ball. A quick sweep to reestablish the x-axis orientation. When you're back on 0, now you're going to hit that original 531 on the print when we walk over. Eighth-inch slot, 1/8 deep. I'm going to set my tool height with a tool bit. That is a 250 thick tool. I'm going to drop the table till it just slides underneath. Do not keep the tool bit under the cutter as you do this. Just like a CNC probe, you'll blow up the corners of the carbide, so don't do it. I'm coming back up with the table until I feel a light drag. This tool actually measures 252 thick, so I'm going to drop down 252 and I'll be at the 0 point. Print now calls out for 125 deep. Let's go 125 deep. There's 100. It's already a partial hole, so a full depth should be fine. Back to the 141 off center both ways. And now we're going for the 531 on the print. All right, that's money. Let's take it out, put it on the bench, take a look. This end is done. Gotta love it. I am very pleased with that. It is exactly where it's supposed to be. And you can see the breakthrough in the ports. Right where it should have been. Actually, let's see if the drill fits back in there. We can show you exactly what that looks like. I'm sorry, but the light just will not allow me to do that. There it is. See the drill? Right there. Both sides. That's a win, guys. Little bit of planning, everything works out real well. I'm going to flip this over and I'm going to finish all these features on the other side and call this one a day. But you've seen everything there is to see. Tapping the holes on this side is just a matter of standing it up, banked off this side because they are parallel. Clamp it, sweep it, drill your pattern, away you go. This is not used. You remove this depending on how you decide to mount the cylinder. So you only use one side. Look how nice and straight that is. Almost like I knew what I was doing. Almost. Anyway, that's it. That's a wrap on this one.